Coventya plating on plastics technology provides an important enhancement to plastic parts for many applications in the perfume, cosmetics, plumbing, and automotive industries today. Commonly referred to as POP, plating on plastic processes have been developed in Coventya laboratories to provide improved appearance and other important performance characteristics for plastic parts. Attached to plating racks, bare parts are ready to be treated in a sequence of different chemicals. The first step of the sequence consists of cleaning residue from the plastic surface. Before processing, the average roughness of plastic is about 25 nanometers. After cleaning, the parts are immersed for 5 to 15 minutes in an etching solution to promote adhesion of the plated metal to the plastic. Etches are chromic and sulfuric acid mixtures used at 68 degrees Celsius. The etching process is designed to increase the micro-roughness of the plastic surface. The topography is roughened to 240 nanometers by creating pores in the plastic, as shown in the SEM photomicrograph. These pores ensure good mechanical adhesion of the different layers of copper, nickel, and chromium deposited later in the process. After etching, parts are thoroughly rinsed with water, then neutralized in a chemical step that reduces hexavalent chromium to trivalent chromium, since traces of the former will poison the catalytic process. Catalyzing the plastic with the controlled adsorption of palladium and tin colloidal particles in the micropores is critical for making the surface conductive. The next process is referred to as accelerating the surface, where a chemical reaction takes place to oxidize tin plus 2 ions to tin plus 4, and palladium ions are deposited on the surface as metallic palladium. After acceleration, the surface is ready for a thin layer of a conductive metal to deposit on the palladium catalyzed surface. This occurs from an electroless nickel process step, which deposits a thin, dense nickel-phosphorus alloy. The nickel alloy layer thickness deposited from the electroless nickel ranges from 0.2 to 0.4 microns, resulting in the plastic parts becoming conductive, which is very important for the deposition of the copper, nickel, and chromium electroplating sequence. After creating the initial conductive layer with the electroless nickel, racks of parts are processed through an immersion copper or nickel solution to further improve their conductivity. Next, a 20-micron thickness layer of copper deposited from an acid copper electrolyte provides leveling of the etched plastic surface, while also producing a bright, smooth deposit. This layer also provides ductility between the plastic and other plated layers, which is important to improve the thermal shock resistance, while also minimizing the formation of cracks when the plated part is in service. A bright nickel deposit from 5 to 7 microns provides protection of the copper layer, gives a final bright aspect, and supports the chromium layer. In automotive industry POP applications, multiple layers of different types of nickel deposits are utilized to further increase the corrosion resistance of the plated plastic. The final chromium layer deposit of 0.1 to 0.2 microns thickness provides a final corrosion and anti-tarnishing protective layer, while giving the surface a bright and decorative aspect. It also provides good shock and abrasion wear resistance. After these simple sequences of process steps, the non-conductive plastic parts are now visually more appealing, with layers of copper, nickel, and chromium that also provide important functional characteristics. Parts are now rinsed, dried, and carefully examined before being shipped to any final assembly for the final application. Technicians will check surfaces for any defects, including pits, stains, hazes, misplating, or cracks, to verify that good quality product is the result for the final customer. The next time you see a plastic perfume bottle, a plastic plumbing fixture, or automotive interior or exterior trim piece, you can now have a better appreciation of what makes that possible.